Well, hello Internet, and welcome to part 3 of my UML2 video tutorial. Today we're going to talk about class and object diagrams. Now, part of this is going to be a review for a lot of you guys, but I just want to go through and talk about everything in this tutorial. Like I've mentioned numerous other times in the past, classes just describe the types of objects that your program is going to use. And class diagrams are going to describe those classes and how they relate. And each object that is created from a class or a blueprint, which a class is often referred to as, is known as an instance or just simply an object of that class. And a class, as you can see right here with this class diagram we have, is just made up of states, which is on the top, and behaviors, which are on the bottom. The states are also known as attributes, fields, or variables, like up here, and the behaviors represent what an object can do or what can be done to that object. And behaviors are also known as methods or functions. However, in the object-oriented world, these guys up here are normally known as fields, while these guys down here are known as methods. Then we get into abstraction. What you have to understand is in the process of creating objects, you want to eliminate as many details as possible until you have a blueprint that applies to all objects of a certain class. So if we're creating animals, we don't want to put any information in here that is only going to apply to a very few animal type objects. So we wouldn't, for example, talk about an animal that has a certain scratch on its one toe. It just doesn't make sense. However, we do know that every animal that we define more than likely is going to have a name, height, weight, more than likely favorite food, speed, and should be able to eat and move and do other things like we have diagrammed right here on our screen. And then we can see here an example of encapsulation, which is another big word, but it's not really that complicated. What we're going to do whenever we encapsulate our fields, as we have up here, is to protect them and not allow outside sources to, for example, give our animal object a name that is just a whole bunch of integers, which wouldn't make any sense because most animals are a string, which is a name that you can pronounce. So down here where we have set name, for example, we would make sure that we have a string coming in, and we would then verify that before we would give our animal object a name, as we would define up here, and that is encapsulation. And the reason why we have to do that is all of these fields are marked using the visibility symbol of private, and they are accessible because down here we use the visibility field of public. And I'm going to get more into what exactly that means. But you can see here whenever you're defining an attribute inside of a class diagram, you're going to show its visibility, which means who can access it, its name, and then its data type. And then down here in the method section, also visibility, its name. Then you can, inside of brackets, either put in different parameters. In those situations, you would put its name and its data type, followed by a colon and the return type. And you can see that laid out here again with a basic method diagram. Again, visibility followed by the name, followed by parameters. Either way, you have to put these brackets inside of here, then a colon and a return type. And then down here, you can see an example where we do pass parameters to this method. Now on to UML class item visibility and what exactly that means. First, you have public. And basically what public means is it's accessible by any of your other classes. And then we move on to protected. And if an item or a field is protected, this means that it can be accessed by methods in the same class and as well subclasses that are created from that class. So if we jump back to animal and we create a more specific subclass of the superclass animal called dog, if any of these fields up here were marked protected, which is a hash symbol instead of a negative, which stands for private, that means the dog objects would have access to these fields. However, since they're private, you cannot access them with subclasses. And then you have package visibility, which means basically anything set as a package or a default, sometimes it's referred to as default, can be called by any other class that is within the same package. And then, of course, we move on to private, and private items are only accessible to other items in the same class. And just so you know, attributes, whenever you create them, or fields, whatever you want to call them, should always be either listed as private or protected in most any situation. And more than likely private unless you want subclasses to be able to access them. In that situation, they should have a visibility listed as protected. Now on to multiplicity. And multiplicity allows you to declare certain roles for attributes that are going to represent a group of objects. And you can see a whole bunch of examples here. So let's say that we want to list between 1 to 10 different types of favorite food for each animal. Well, you would just put 1.10 inside of brackets, and that is exactly the role that you would set there. Let's say that we also would like to have a group of friends for every animal. However, we have no idea how many friends this animal might have. In that situation, we put a star inside of there, and it wouldn't make any sense to have friends listed more than once. So in that situation, inside of curly brackets, we would put unique. And of course, you could put not unique. And in those situations, like you can see down here, you would put not in lowercase letters, followed by unique with an uppercase U. Then again, you can see here, if each animal object is going to have a whole bunch of owners, however, we have no idea how many, and we'd like to list them in the order of ownership, we would put this as an ordered grouping. And if we would like to list a favorite number and then say that animal object can never change it, in that situation, we would list that number as read-only, which just simply means once it's set, it cannot be changed. And the final thing we'll talk about in regards to class attributes is the use of static attributes. If you ever want to define a static attribute, which will be shared between all of the class objects that are going to be created from type animal, in that situation, let's say we wanted to keep a tally of the number of dogs for every object. In that situation, it wouldn't make much sense to have this be a class attribute. We would simply underline it, and anyone who sees your class diagram would know that the attribute number of dogs is a static attribute. Then we move on to something people like to argue about a lot, and that is probably because it's not used all so much, and it can be kind of confusing. However, I don't like to argue about it, so I'm going to briefly just give you a rundown of what goes on here with dependence. Dependence comes down to the fact that whenever you are going to be designing classes, you want to avoid creating classes that are what we call tightly coupled. And by tightly coupled, what we mean is we don't want classes in which a change to one class is going to force all kinds of other changes in another class or many additional classes. If that occurs, this is called tightly coupled classes. We want to instead have loosely coupled classes. And dependence is an example of class dependence that is very loosely coupled. These guys have almost nothing to do with each other. So let's go into a dependency-dependence relationship between classes. Here we have an example where we have a dog object that can be passed to a method of the class washAnimal. In this situation, it is just simply passed in as an attribute, and then let's say maybe we print something out the screen that has the dog's name or what have you. And then washAnimal is done with dog and has no other relationships with dog in absolutely any way. It is just simply used on a local level inside of a method and then discarded. This is but one example of a dependency relationship between two classes. And just so you know, this is how you would show that relationship between these classes, but also know that whenever people are creating class diagrams, this is often not shown. If it was shown, you would have arrows all over the place when you're creating class diagrams. So now you know what it looks like, but more than likely, it's best to not use it whenever you're creating your own class diagrams. Then we move on to the association dependence between classes. With an association, and again, this is something that's not often shown inside of class diagrams, I just want you to know what it is. If you have classes that have a direct relationship with each other, but don't necessarily have attributes attributed to each other, like we have in this example, this is known as an association dependence. So for example, we have teacher classes and we have student classes, and we might have schools down here in which teachers are directly related to students, and we know that teachers have students and they wouldn't be teachers without students. They are, however, the way we have this structured right here, not directly dependent upon each other, even though they are related in one way or another inside of the school class. This is known as an association relationship. They are connected inside of another class, however, they're not directly dependent. If that's at all confusing, don't really worry about it. In the next part of the tutorial, I'm going to get more into this stuff and clear everything up. That is but just one example of an association dependence. Then we get into another level of dependence, and this is known as aggregation versus composition. And in most situations, aggregation and composition relationships are going to occur between two objects at the same time. So in this example, breed has an aggregate relationship towards dog. Every dog is going to have a breed of some sort or another. And then, to look at this further as an aggregation, dog is the aggregate of many other objects that describe it like breed does. Breed may be used in many different composite instances. Just to make this a little bit more understandable, it is possible for many other different dog classes to all have a breed, and maybe have the same breed, however, be completely different objects on their own. So each dog's going to have a breed, however, those breeds may be different from each other. That's the aggregation. And again, this is not often shown. This is a filled-in little diamond. Composition, however, is often shown in class diagrams. And what that shows is dog has a breed. As you can see here, breed, which would just be a simple string word, is listed as an attribute inside of the dog class. And that is known as a composition relationship, because breed makes up every dog class that we are going to define. So hopefully that makes sense. We've talked about composition in the past, so that shouldn't be that big of a deal. And then finally, the last level of dependence is inheritance. And with inheritance, we have example of a very tightly coupled relationship. And this is when we have a subclass that is created from another class. Here we have a subclass named dog that is created from the animal superclass. And whenever we create any subclasses, all fields and methods are shared between these guys if those fields and methods are marked as public, protected, or default. Now let's move on to constraints. Constraints are used inside of class diagrams to define rules for parts of your classes. So let's say down here we absolutely positively want to make sure that every single dog has a name. Well, we would just simply draw a dashed line and then put self.name and mark this as not empty. However, we do have other constraints that get much more deeply into this rule set. Here are pre- and post-condition constraints. Preconditions must be true before a method is executed. And as you can see, here is an example, and this is exactly how it would be drawn up in a class diagram. We're going to first list it as pre and say that balance must be either greater than or equal to 0 before the method over here, setBalance, is executed. And that just means that we're not going to leave the balance or price or money owed on a dog that is purchased to ever be a negative value, because that doesn't make any sense. And then we also have post conditions. Let's say that we are never going to sell a dog that is more than $100. In that situation, we want to make sure that the balance never has a value that is greater than $100. And that's exactly how you would define it there. And you could also define all of these rules using just basic notation, which I'm going to get a little bit more into here in a second, between curly braces, or use them or display them as a note like I have over here on the right side. So now let's get into how to define these constraints. They are often defined either using basic programming nomenclature, the way that you would normally describe things, or through something called Object Constraint Language, or OCL. Whenever you're using OCL, you would define all of your data types as either Boolean, integer, real, or string, and by real I mean numbers that have decimal places. And here are a list of the most common forms of arithmetic that you would use whenever you're defining certain constraints. And this guy right here represents modulus, which is a reference to the remainder that is available after a division, and an absolute, minimum, and max. If you want to compare everything, less than, greater than, less than or equal to, greater than or equal to, or not equal to. And then finally, Booleans are compared with and, or, XOR, or not, and I trust you know what those mean. Then we get into abstract class diagrams. And like I've talked about many times before, whenever you're creating abstract classes, some of those methods are going to be defined so that subclasses have to implement all of the code. And if you have an abstract method defined inside of an abstract class, you can see here the abstract class has to be listed as italic, and the abstract method also must be shown in italics. That's how you define that they are abstract. However, non-abstract methods would not have to be listed as italic. And that is the basic way you would display those. And here you can see a subclass that is implementing all of the code that is needed to make these abstract classes work and make them happy. And here you can see that we use the basic arrow type that is used whenever we are showing that one subclass is inheriting certain methods from a certain superclass. Then we get into interfaces, and they contain only abstract methods, and all of the attributes are either going to be static or constant, and you can define interfaces inside of class diagrams, either using ball notation as you see here on the left side of the screen with the name of the interface underlined, or you can use a stereotype, which is this guy right here, that lists this as an interface and the interface's name, and in this situation, you do not list those methods, which are all going to be abstract, in italics. However, if you did, I don't think anybody would kill you. And then finally, all on one frame, I'm going to explain the basics of object diagrams. Object diagrams are very simple, and they are just basically used to describe how objects are going to work together. You can see here we are going to define 4 different types of objects. So here we have game board, and you wouldn't have to put the class name in here, but if you did, you would put it second after the colon, and this is the name of the object that would be defined. You could also put notation inside of here that shows that game board is going to display an enemy ship if we're making some sort of video game. You could also use the keyword contains to state that the enemy ship is going to contain an engine. And then up here, this weird looking thing, this is an example of an anonymous object, which of course would not have a name, hence anonymous. And in this situation, we're just documenting an action listener, which is a guy that's just going to grab certain events whenever they occur on the game board. And in that situation, it's common to actually document the method that exists inside of this anonymous object so that you can see certain actions are performed, an event is passed over, and then things happen. So that is a basic rundown of class and object diagrams. Leave any questions or comments below. Otherwise, till next time.